Hello and welcome to TidyX episode 34. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And I'm Patrick Ward. You can find me on Twitter at OSPPatrick, and you can find both of us on Twitter via the TidyX handle at tidy_explained, or you can hit us up on Gmail at tidy.explained@gmail.com.
Awesome. Alrighty, so this week's code that we're going to be going through is a submission to the Tidy Tuesday dataset, as we usually do. This week's dataset is on Canadian wind turbines. So this is data from the Government of Canada sharing, here's all the wind turbines that we have in Canada, and here's where they're located, and various information around that. And there's a lot of fun ways that people did it. People were getting pretty creative with it. But what we wanted to do is we wanted to kind of continue a theme from last week, which is maps. So we saw a good set of maps produced showing various ways that you can look at it. But one that we thought was pretty interesting is combining external data into the map along with the actual wind turbine locations. So this is from Florence Dubois. And so this is her image that she created. And I thought first, very visually appealing. When I look at that, I was like, oh, wow, that's a lot of color. And you can almost immediately look at the color scale and go, oh, things are getting darker in that lower section of the plot and a little bit lighter. Oh, and there's definitely a lot more wind turbines in the lower part of the plot there as opposed to the upper part. And then you look at the title, or at least that was the way that I kind of looked through it, as I got, ooh, colors, because, I'm a child. And then I read the subtitle, and it said, the colors indicate the level of support for increase in taxes on carbon-based fuels. And so the darker the color, the more support there is, based on the color scale there. So I don't know, you could maybe draw a connection between number of turbines that exist and support of taxes on carbon-based fuels, because maybe they won't be as heavily impacted by those taxes. I don't know. I've never been there, so I don't know what the culture is around that. Patrick, do you have any other comments around this?
Nope, it's a pretty cool looking plot. I do think the one interesting thing is the big portion there in the left where there's like that middle section right there that's super red, one of the reddest on the map, and there's no wind turbines near, like in their little voting region. In that voting region, there's 0 wind turbines, but they seem to be very in support of carbon-based fuel taxes.
Yeah. So I don't know. Any Canadian viewers, if you want to kind of explain this, is New Brunswick, Nova Scotia, and Prince Edward Island. Of course, we are horrible at geography, so we had to look up where everything was on the Google Maps, so we knew where it was. So sorry about that. But so anyway, moving forward, sprightly ahead, she shared a bunch of information about how she made the plot as well as the code itself. So we reached out to Florence, like, hey Florence, you mind if we go through and explain how you created your pretty awesome plot here? And she said, yeah, go for it. And so we have it here. We pulled it all down. One thing we should mention is we had to work with her to get some external data that she's given very clear instructions on how to pull this information from online. She just didn't want to share it off of her GitHub, which totally makes sense. And so read through her comments if you want to try to recreate her plots. They're very clear on how to do that if you read French. I was pretty lost. I don't read French. I don't know French. So, but anyway, let's go through her code right now. So the first thing, as usual, is she's got a bunch of library statements here at the very top here. Tidyverse. MapCan is a package that contains shapefiles for Canada. So that's for maps. The RGDAL, which I think is another map package. RMap Shaper, SP, SF. Leaflet. So these are all mapping packages. So there's a lot of different ways you can approach the mapping, clearly. Leaflet is pretty cool. It creates a mapping widget. I don't think this actually ended up getting used in the code, but that's fine. And then ggtext for making very nice labels and whatnot in your ggplots. So, all right. So then the first thing here is a big comment explaining what the goal is and where the data came from that was external, which is Mildenberger et al., the distribution of climate change public opinion in Canada. It's from PLOS One. So you can definitely check that out. Definitely an interesting read, I'm sure. One thing we did want to note is typically if you find yourself putting a lot of comments like this in your R script, it might be better served to move over to an R Markdown, because then you can just write normal text. You don't have to put it in comments at the very beginning and try to like make it fit in readable format there. It's just naturally going to like flow over. And then when you go to generate your results, you have all your comments there in a final report. And so that's just, just a comment there that it might be helpful if you tend to be writing these long comments there. If you don't have to be doing it in an R script, it might be better served in an R Markdown. Then next, she loads in the Tidy Tuesday dataset using readr read CSV, which Thomas, still provides. Immediately after reading it in, she does some filtering to filter it down into the areas we are interested in, which is Nova Scotia, New Brunswick, and Prince Edward Island. So the way she did this is the province territory is the name of the area, and then equals Nova Scotia. This vertical bar means or. So it's going to identify Nova Scotia or New Brunswick or Prince Edward Island and keep all those records. And then adds a mutate count equals 1 and a group by. I'm not quite sure what this group by is doing because I don't think we end up doing any grouping later on. But so we'll run that. Oh, I did the thing that I always do and didn't run everything. I talked about it and didn't run it. So we did that. Alrighty, so then we take a look at latitude, just a quick peek at that just to see what it looks like. And so that's the latitude. Patrick, do you maybe want to take us through this next piece?
Yep, so now she's going to snag, we're going to snag the data from the Mildenberger study that she was nice enough to provide to us, which at the top there are some ways of accessing this through the University of Montreal's website. So read CSV, we're pointing it at our project for Tidy Tuesday Explain number 34. We're going to pull in that data. It's separated by a semicolon. And we'll go ahead and let's see. Oh,
so that was something I added.
Oh, okay.
As I was looking at stuff.
Then she's doing some filtering here. So filter does not equal GeoID equals national. So removing Canada from the observation. So that must mean that there's some sort of aggregate for Canada, probably within the data set or something like that she's just dumping out. Then mutating her GeoID, she wants to turn it to a numeric value. So she's using that as numeric. The levels piece here probably could have just done as numeric GeoID. I'm not sure what it looks like before that because the pre-processing is happening within the read CSV.
I mean, we can run it here and.
Yeah, let's just take a look.
GeoID. So it's that. Let's just do a head. So they're numbers, but they are factors. I do know that. Oh, they're character.
They are character values. So you probably could have just done as numeric GeoID. I think would have gotten you there, because you didn't need. I don't think we would need levels, but let's see. Yeah, should work, right?
Yeah.
I think, right?
Yeah.
No, those are different.
No, these are correct.
Is it?
These are the values we want. I've gone through this code, so yes, this is.
Yeah.
This is right. And if you look here too, she's filtering.
Oh yeah, those are okay. Yeah, so you could have done the as numeric there. Either way, it's going to work.
We'll leave it as it was.
Oh, yep. Yeah, leave it as it was. And then she does some filtering. So she's saying when it's not GeoIDs less than 100, we're filtering those out. So basically, that's the same as saying when GeoID is greater than 100, actually greater than 99. It's inclusive of 100. Yeah, greater than or equal to. That would get you the same value. And then there's a little bit of a filter between two values here. So if GeoID is greater than 1100 and less than or equal to 13999, keep that as well. And so we'll run that, and that gets us, whoops.
What did I do?
I think
I'm assuming I'm the one that messed something up here.
No, I think it's what you have in the console. Get rid of that. Oop. Yeah, now try it.
No. Okay, I'm gonna undo whatever it is that I did. Hopefully this will now work. Okay, there you go.
There we go. All right. Cool.
Oh, yeah. So never mind. Continue.
Yep. All right. So now we've got the Mildenberger data set in, and now we're pulling in the shapefiles. So this is the shapefiles is going to be the file that's going to define the shape of that map, right? So how it's going to be plotted out. So she uses the read OG R function. I've never used this before. It's for shapefiles. I've never used shapefiles before.
Yeah.
So.
Yeah. So this is definitely like the more difficult way, I think, to go through and creating a plot. But this also then gives you the ability to actually have the shapefiles itself. So there's a couple different, obviously several different types of maps that you can produce, right? So this, so one that we're going to go through and explain in the next piece, the part that we do, is we're overlaying points over a plot itself. Here she wanted the actual shapes of the areas of interest. So these are the voting districts or
polling stations, or whatever.
Those areas there. And so she wanted actual shape of that area there. And so that's when you need shapefiles. Is to pull that out there. And so read OGRs from the RGDAL package. DSN, I don't know what that actually stands for, but you point that to the data source name. They're explaining it if I read through closely. So you want to point that to the folder that has the shapefiles in it, and then you define the layer of information you're wanting to pull out of it. Because typically these shapefiles have lots of information kind of embedded into it, and this layer tells it, okay, what I care about is this, because a shapefile could have a ton of information in there that you don't care about for your plot. And so this is going to be looking at the shapefiles that she very kindly provided a link to where you can get these shapefiles as well. She provided them to us so that we could directly reproduce her plot. So path to the shapefiles, and then we're going to be pulling out the maritime boundaries layer from those shapefiles.
Yep.
So that is kind of what's going on there. It's a little weird, but it does some cool stuff. There's a lot of information embedded in these shapefiles. So folks that work in GIS or that sort of work, they deal with very interesting data, I think.
And so now you have that boundaries. I don't even. It's not a data. I don't know what it is. It's a shapefile.
Yeah.
But she's going to change the coordinates to decimal coordinates. I think when we did the and that's why at the top she ran the what type of variable the latitude was, the class, right?
Yeah.
It was numeric. I think here this is what's going to change longitude, latitude to a numeric value. So she's got to get it onto the same coordinate system that's in the original data set for the points to be plotted properly.
Yes.
So that's functions.
Exactly that. It's also changing the coordinate system. I think it's making it using the same transformations that's used for the wind turbines as well, because it's really important that you're using the same coordinate system when you're trying to plot two things over each other. What? So yeah, this is what SP Transform does. Next, we're going to do this MS Simplify. So what this is going to do is these shapefiles have, like we said, a ton of information in them. But for our purposes for plotting, we don't really care for it to be incredibly accurate. Like these like trace outlines, and so they have a ton of points there. But for our purposes, we're kind of looking at it at a high level, so we don't need that level of detail. And so what we're going to be doing here is we're going to be simplifying these shapefiles so we can plot them quicker. And so this is what MS Simplify does. So we input the boundaries, which is shapefiles essentially. We're going to keep at a level of 0.1, so only keep 10% of those original points, but make sure that the overall shape of the polygon, which is the shape that it's generating, is more or less kept the same. So that's what MS Simplify does. I mean, I guess you could try to come up with your own way and, I don't know, randomly subset. But I don't. Yeah. I would say that's probably not the better idea. Trust somebody else that spent some time to figure out the best way to be doing this.
Yeah, for sure.
And I think there's like some iteration you have to do with the keep to make sure that you're keeping the level of information that you want while balancing the speed at which it'll plot.
Yeah, right.
So let's run that. And so here you go. Here are the shapes that we have here. And so when we first looked at this, we were a little bit confused because we were expecting it to like actually shape the outline of like the island and Nova Scotia and New Brunswick. But these are regions. This isn't the geographic like actual shape of the island. So this is
Prince Edward Island.
Prince Edward Island, yes. But this is extending out past the actual land boundaries and into the water, and that's just typically how those are done for regions. And so we will step forward. So now we're going to do some broom tidy. So this is to transform this shapefile that we've got here into a data frame, so we can actually do stuff with it that we're used to be doing. So we can just treat it like a data frame, and then we want to be keeping the fed num, so identifies the lat longe and it adds the federal electoral district to it. We're going to be filtering again to keep only New Brunswick or Nova Scotia, New Brunswick, and Prince Edward Island. And then going to convert that ID, which is the same as GeoID that we were working with earlier, into a numeric. So there we go. So this is what we got here. So we got lat and longe, which are the coordinates that we care to plot. I'm not quite sure what these things in the middle do. I'm sure they're important. But what we care about is ID, which is the same as GeoID. So what we get to do here is to add in the Mildenberger data into our shapefile is we just do a left join, and we've got all the information we care about.
There you go.
Ba-boom. So now we've got all that information there, and now we're able to go to our plot. Yay! So you add in the writing's opinion dataset into your ggplot. You set your generic aesthetic, so x is equals to longe and y is equals to latitude. You're going to use Geom Polygon to actually draw the shapes now, and so the aesthetic is we're going to use the group field there so that it's differentiating between each of the shapes that it needs to be drawing. We're going to fill those shapes based on the carbon tax bin, which is from the Mildenberger dataset, and it is the positive opinion of a carbon tax, and set the default background color, so the color to be white, so that's the boundary. Then we're going to use chord map so that it treats it like a map and tries to keep it square and all nice. This is telling ggplot how to behave. Theme map Canada, or theme map can, which is from the map Canada package, so it's adding that nice theming there. Now we're doing the Geom Point, which is actually we're going to use the data set from the wind turbines. The same y is equals to latitude, x is equal to longitude. They're going to be colored midnight blue. They're going to be an alpha of 0.4, size of 7, and a shape of 8. So the shape of 8 is a star, essentially. And so now it'll be drawing the locations of each of the wind turbines on top of the voting districts, or federal electoral districts that we've got there. Now it's a bunch of styling of our plot here. So we're going to be setting the fill to be using the palette. So the Psycho package, SCICO. Psycho.
Is that? Yeah, I guess so.
It's going to be setting this fill to be using the palette La Jolla. It's not going to have a name. We're setting the limits to be between 35 and 65. And then we're setting the guide. So we're telling it that we want the color bar to be a vertical line there. Otherwise, it could be horizontal. Scale color manual white, so make sure that the outlines of the polygons are white. So they're clearly differentiable from the fill. Now a bunch of theming, so get rid of the panel.border element blank, so get rid of the panel border. Setting the legend position to be these coordinates here in the plot. Legend background, make it white. Legend key height, make it 2 units tall. Legend text. So now we're setting all the text in the plot here to be midnight blue. So element text color equals midnight blue, and now we're setting the sizes. So text, the legend text is going to be 12. Legend title is going to be 10. For the plot title, it's going to be a bigger size of 20. We're going to center it with HJust equals 0.5 and face equals bold, so it's a little bit bolder here. Subtitle, just a slightly smaller size, same HJust, so it's also centered. And the caption is going to be a smaller size 10. Guides, color equals false, so we're not going to be, this is saying don't draw the color guide, so the legend for color, because we set that to be white manually. We don't want that guide, so the legend portion for that to exist at all. So that's now gone. And now her labels. I did also edit it because normally she also is doing an immediate GG save out of this. I tend to not like to do that because I like to be iterating with my plots, and then I'll just save the one that I end up wanting to keep. So I also commented that out so it doesn't accidentally run. All right, here, let me zoom out for a little bit. Let me pull that out so that it'll plot, move that. Did I not run everything? What is going on? Call graphics. See, I was getting this before, and I fixed it by just rerunning everything.
When in doubt.
When in doubt, just rerun it. Or, yeah, see? It worked. It worked. See?
Yeah. I don't know.
Computers be weird sometimes. Sorry.
They do exactly what you tell them to.
That is also true. So I told us to do something wrong. So we'll give it a second. All right. So here's that same plot that Florence created. So once again, same sort of conclusions we're coming to here because it's the same exact plot. I thought this was a lot of fun to kind of go through and do the nitty gritty, like difficult mapping, like that you really have to think about. And what I find interesting often with mapping is I spend more time actually dealing with the shapefiles and trying to create the map itself than I do the putting the data onto the map. Like that's the easy part of map, for me at least. It might be because I don't do it very often.
Yeah, totally. Pretty cool though. Actually, really cool map. Lots of different elements to play with there, and kind of trickiness with getting this right. So, yeah, I really liked it.
Yes, thank you so much, Florence, for letting us go through and explain your code. I think people will find this incredibly valuable. So now we're going to hop over to a script that Patrick came up with. So I am going to restart the R session. Patrick, if you want to maybe explain some background.
Yeah, so I noticed this week's data was going to be the Canadian wind turbines. I kind of had a feeling that people were going to do a lot of maps, so we dug into the comments on one of the YouTube page where someone asked about Garmin data, and because I think we did a map once before, and they said, "Oh, can we do anything with Garmin data?" So I decided to take my run from yesterday and create a map of it, and essentially reproduce what some of the reports look like if you're inside of your Garmin Connect account. So if you have a Garmin watch, you go to your Garmin Connect account, you sign in, you click activities, You click the little gear up in the right-hand corner, and that'll give you an option to download that activity as a TCX file. And so I just download that file, and that's what we get here, and we're going to read that in. So we'll load our libraries there. We're going to use Tidyverse, obviously. I didn't use Shiny. I was going to do this as a Shiny app for several runs. It just ran out of time, but maybe next time. We are going to use ggmap. That's going to make things really simple for us. We're literally going to, as you'll see, set the map that we want and put our plots over it. And then we use ggpubr for a table and patchwork to wrap everything together. We set our theme to light. I read this TCX file in with this tracker package. Tracker is a cool package for working with GPS data. So anytime you have like Garmin data or Nike Run data or something, any GPS data, running, cycling, swimming, endurance athletes, this is a great package to kind of pull data in. It has some other functions for processing that data and things like that. So we're going to read the TCX file in. I do a little bit of pre-processing to the data set right up front. I just grab the date out and turn it into an actual date, so we have that. And then obviously I'm going to remove some of the stuff that pertains to cycling, since those are just NA columns as I wasn't riding a bike, and temperature was also NA, so I just get rid of those. So now we have a data set that's this is basically if you download the data from your Garmin Connect account, you can download it aggregated as the session, which is fine. I prefer to download this as the raw data, second to second. So there you can see the latitude and longitude, and you can see the latitude is changing over time. You'll see why when you see my map. I ran pretty much a straight line. But you can see the changing over time. And so this is the raw second by second data that's moving through here. Okay, so we got our data pulled in. I'm going to create a metadata data set that just summarizes the entire session. And we're going to do this so that we have something cool for a table within our report. So I'm going to take that DAT column, DAT data frame, and I'm going to summarize it. We're going to calculate distance to be the sum of the distance between distance and lag distance. And then I do a little bit of multiplying. I wrote some notes up above. So when the data comes out from Garmin, you'll see that it comes out in meters. So I just have the calculations up there to make this simple for anybody that's doing this with their Garmin at home. So the numbers that you see down there are the calculations. So we're going to calculate out my distance over the entire session. We'll put it into a miles unit. We're going to calculate duration in terms of hours. So the time column there that you see on the bottom left in the console is a POSIX
CT is how I call it.
POSIX CT, that's what it is. POSIX CT time. So we can use the diff time function from base R to calculate out the difference between the last row of the data set and the first row of the data set. The difference between those values will give us time, and we call for it in units of hours. I then do some max speed calculation here. So they are nice enough at Garmin to give us a speed column. Otherwise, we would have to probably take our latitude and longitude, convert them into like a numeric XY value, and maybe I'll do a separate blog on something like that. But for right now, they give us the speed column to work with. So all I did was transfer it from meters into miles and get miles per hour. So the max speed by miles per hour, and then my average speed by miles per hour. And we were going to use this in the table, but then eventually we'll delete it because most people think of running in terms of minutes per mile, like what was your mile pace. So we transfer that into a minute per mile pace. So we've got minutes is 60 divided by the speed in miles per hour, and that's going to give us our mile pace. And then just a little bit of physiological data, throw in the max heart rate and average heart rate just for kicks. So everything will be in a wide format. I'm going to take everything, all those columns, I'm going to slug them into a long format so that we have what will be a nice kind of looking vertical looking table for the report. So we can run that. Yeah, there we go. So that's what that's going to look like. All right. So now we're going to deal with the map. We're going to get the maps and the plots ready for our report, our final report. So we'll scroll down here.
Yes.
So here's our map. This is literally how easy it is to plot one of these maps. The first thing that you need to do is you need to get the coordinates for the map correct. The map that you're going to extract from the get map function. So I set my latitude and longitude to be the min and the max of the corresponding latitude and longitude within my data set. That's going to define the parameters of the map that I want to extract. And then I create this little box that says make box, and we can run this over the latitude and longitude that I just created. And then if you run that, you'll see this is going to define the left and the right and the bottom and the top of the map that we're about to extract using this get map function. So we're going to take that bbox object that we just created. We're going to put it into that get map function. We're going to say, hey, use these longitude and latitude parameters and select this out. Select the map out using this source. There are a ton of sources and a ton of map types that you can use. It's totally up to you. That's just the one that I use, but you can.
There's a ton of options here.
If you were doing like a hike or something like that, you might use the terrain one, terrain line. Yeah, exactly.
Terrain background, satellite even.
There was road map. That might have been a decent one for this run, but either way, pretty cool. Lots of options, and so now we have a map to work with, and it's literally as easy as putting this right into a ggplot. We use ggmap, we dump that map in, and now we're saying, hey, we've got that map, put these points over it. So we're going to take my data, we're going to plot our x and our y, longitude and latitude, and we're going to color this by speed. And I like the colors of speed to be set as the lows to be yellow and the reds to be high when I'm really moving fast, you know. Exactly. And then I give it a name, obviously.
It was in meters per second.
Yeah. Yeah. And then our theme axis is going to be title is blank. So I just take away the longitude and latitude. They don't give us any extra context because we're just looking at the map here. And I call it half marathon since that's what was the distance that I did yesterday.
This crazy man ran half a marathon yesterday.
Yeah, 4 a.m. Got to get it. So there's the map. Now, I think next time I do this, I'll do the run in more of a circle. I just literally ran out and back.
So this is probably really capturing your speed on your way back.
Probably.
Because it probably overlaid.
Right, they're overlaid. So it's not super exciting map, but you can see my meters per second there. I should have probably turned the speed into miles per hour or something like that, but that's okay. All right, so that's our first map. The next plots, we're going to do one of heart rate, and we're going to do one of speed over time. So I take the DAT data. I'm going to put X axis is time, and the Y axis is my heart rate. And I'm just going to ask for that as a line plot, and then I'm going to fill in the white space under that line plot using the area plot. And the reason I did this is if you go on your Garmin Connect account or in your app, that's how it shows it. So I figured I'll show it like they do, and it kind of looks cool.
Yeah.
So I dump the area in there, and then I actually just call for a Geom H line, and I give it the mean of my heart rate. That's the intercept that I want on the y-axis, so that I can see all the times when I exceed my average heart rate or drop below that. Little bit of labels, time, heart rate, give it a title, and set the y limits to 0 to 220.
Yeah, because without this, when we were plotting it, it was going up to like 300 or something like that. And I don't think your heart rate's supposed to go to 300. I think that's
my heart rate's not getting up to 220.
No, but like 220 is supposed to be like,
yeah.
At least that's what I remember.
General, right? The general
max
formula. 220 minus your age, right?
Yeah.
So there you go. So there's a cool little heart rate plot. We'll do the exact same thing. We could copy and paste this down, the exact same thing for speed. Here I actually do convert speed to miles per hour right there, so with the little multiplier. So do the same thing for speed, and then we're going to take so there you go. You can see kind of the blips. Some of those might be stopping at a red light. Some of them might be stopping for a second to change my podcast because I finished one. And some of it might just be areas where the satellite, loses lock on the GPS satellite. It loses lock on my watch, and so it just drops out for a second and then kind of comes back online after a few seconds, which is not uncommon with GPS.
Mm-hmm.
Then we'll take our metadata, and we're going to again, we're going to slice out a few of the columns that we decided we didn't want in the table. So we get rid of the full distance. We know it's 13.1. We get rid of duration. It was
No, this is keeping them.
Oh, sorry, keeping. We're keeping distance and duration, and then we're going to keep the mile paces and the heart rate information. So we're just going to get rid of the max, the miles per hour speed. So we're going to put this into a cool little GG text table, just like that, which looks kind of nice. And then we're going to use Patchwork, which is a
wonderful Patchwork.
Super handy package for putting these plots together. And we're literally going to, so we got map plot on one side, and then the vertical bar, we're going to put everything else on the other side. That's why it's all in parentheses. And we're going to stack those one on top of the other using the little slash line, the division line there. And this gives us a fun little plot of the run. So we have a half marathon, we've got a map, we've got speed plotted over the run that I did, we've got a table at the top which gives us some information, and then some heart rate and speed information at the bottom. And you can imagine, like I said, we'll, I thought about maybe it will do like a Shiny app. I'll do a Shiny app or something where you could select the days and see it over time, and maybe have a tab that actually tracks you over time, and you can see change in fitness and things like that. Super simple map, pretty fun to kind of play with these and look at. And there was my half marathon from yesterday.
There you go. I think it's so cool how consistent you were with your speed. Like it's just
consistently slow.
Average about 5 miles an hour. Hey.
Yeah, I think what was my average? 12.2 minute mile pace. So yeah.
I mean, definitely not bad at all. And then, definitely better than I can do. So.
There's the average heart rate, about 150-ish, 151. There you go.
That's how you can pull out data from your Garmin, plot it in a map so you can look to see how it is relative to other things. You can add a lot more to this as well. There's a bunch of other mapping tools that exist as well that we might be going into in the future. Leaflet, I think, would be a fun one if we get another mapping data set. And yeah, so I think with that, we can call it. All right. Go. Well, as always, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick, or you can find both of us on Twitter at tidy_explained, or you can email us at tidy.explained@gmail.com, or you can comment on the YouTube page, which is where the comment for asking about the Garmin data actually came from. So we do read those comments, and when we find the appropriate Tidy Tuesday to kind of splice them in, we throw them in. So there you go.
We try to do it. You don't need to ask multiple times. We do keep a record of it in our heads. So
Ellis does. He's got a much better memory than I do.
But all right, thank you so much, and keep on exploring your world.
Thanks.